Hello, calculus fans. Let's evaluate the limit as h approaches 0, 4 plus h quantity cubed minus 64 for h. Let's define f of h to be equal to this expression. And first thing we're going to try is the direct substitution property. It's the thing we should always try first. Sadly, it doesn't work because we end up with a 0 in the denominator. So let's do some algebra. So we're going to start with our limit, and we're going to multiply out this right here, the 4 plus h cubed. So that's equal to 4 cubed plus 3 times 4 squared times h plus 3 times 4 times h squared plus h cubed. All of this right here coming from this is because of the binomial theorem, which is a way of multiplying out powers of binomials. If you don't know how to use the binomial theorem, you might want to check that out to see how that's done. If we clean this up, we get the limit as h approaches 0 is 64 minus 48h plus 12h squared plus h cubed minus 64 all over h. Now see that the 64's cancel out, and we're left with the limit as h approaches 0 of 48h plus 12h squared plus h cubed all over h. Let's factor out an h from the top. And the purpose of doing this is that we can cancel an h in the top and the bottom. Remember that the canceling is legitimate because we don't care what happens at h equals 0. It doesn't matter. So now we get the limit as h approaches 0 of 48 plus 12h plus h squared. And here is a case where we can use the direct substitution property and just plug in h equals 0, and we get our answer of 48. And keep in mind, again, that our cancellation that we did is valid because we do not care what happens when h is equal to 0. Okay, that's all for now.